Let's talk about nondisjunction. Nondisjunction is basically a screw-up in meiosis. Now you know meiosis is making gametes, right? Making sperm or eggs. So if nondisjunction occurs, I'm going to make sperm or eggs that are screwed up, for lack of a better word. Specifically what happens is the chromosomes do not separate properly in meiosis. So because they don't separate properly, I'm going to end up with sperm or eggs that have either too many or too few chromosomes. And if that occurs, and then one of those sperm or eggs are fertilized, I'm going to have offspring with either too many or too few chromosomes. Now the normal correct number of chromosomes for a human being is 46. Any more or any less could be fatal in some situations or lead to a disorder in others, depending on which chromosome is involved. Nondisjunction can happen during meiosis 1 or meiosis 2. So let's take a look at nondisjunction during meiosis 1. Here I have a cell with 4 chromosomes. If this cell is going to go through meiosis, I would expect to make 4 cells. And because meiosis is reduction division, the cells that I would make would have half as many chromosomes. That is, they would have 2 chromosomes. So let's take a look. All right, the first thing that's going to happen before the cell can divide is each chromosome got to double itself. There we go. And of course, that happens in the S phase of interphase. Okay? And then eventually those chromosomes are going to line up opposite their partners at the halfway point of the cell. And the spindle fibers will grow out to attach to the chromosomes, and they will be pulled to opposite poles of the cell. But here you can see, for whatever reason, this chromosome is not attached to a spindle fiber that will pull it in the correct direction. It's attached to a spindle fiber that's going to pull it in the wrong direction. So if we follow this through, we can see that one of those chromosome partners was not pulled to the correct end of the cell. So those cells are going to divide, and then each of those cells will now go through meiosis 2. And we'll assume that meiosis 2 happens normally because, nondisjunction is a pretty random thing. It doesn't always occur. It's pretty rare, and when it does occur, it would only be with 1 chromosome. It's not like every chromosome would do it. It would just be 1. So here's meiosis 2, and meiosis 2 is happening normally. The spindle fibers go out, they pull those chromosomes apart, and then the cell will divide. So I've got 4 cells, which of course was what I expected. But I was expecting to make cells with 2 chromosomes. And I don't have any of those. I've got cells that have either an extra chromosome or a missing chromosome. And if one of these were a sperm or egg and it was fertilized, I would then have offspring with either an extra or a missing chromosome. Okay, so that's nondisjunction during meiosis 1. Let's take a look at what happens when nondisjunction occurs during meiosis 2. So in this situation, we'll assume that meiosis 1 is going to happen normally. Again, nondisjunction is pretty rare. It doesn't always happen. So here's meiosis 1. So chromosomes double. They find their partners. They line up at the halfway point of the cell. The spindle fibers extend out and pull those chromosomes to opposite poles of the cell. And the cell will divide. I now have 2 cells. Everything's going just swimmingly so far. Nondisjunction occurs during meiosis 2. This is where we'll have the screw up. So in metaphase, you can see the chromosomes are lining up at the halfway point, and the spindle fibers will reach out to attach to them. Now here you can see that this spindle fiber, for whatever reason, did not make it and is not attaching to that chromosome as it should. So when those spindle fibers begin to pull those chromosomes apart, that chromosome is not going to be pulled apart. Or it might be, but it's going to be pulled to the wrong pole of the cell. And now that cell is going to divide. Those cells are going to divide, and I'm going to have 4 cells, just like I expected. But now, well, I can see at least 2 of the cells are normal. 2 of the cells have 2 chromosomes, which is what I was expecting. But 1 cell is missing a chromosome, and 1 cell has an extra chromosome. Now, if this were human beings, if this occurred in human beings, we know that human beings have 46 chromosomes. If this occurred in human beings, I would see 2 cells that have the correct number of haploid chromosomes, so 2 cells that have 23 chromosomes. 1 cell would be missing a chromosome, so instead of 23, it would have 22. And 1 cell would have an extra chromosome, so instead of 23 chromosomes in a normal sperm or egg, I'd have 24. And if either of these 2 cells were fertilized, then I'd have offspring that had either too many or too few chromosomes. And that could lead to Down syndrome, Edwards syndrome, Klinefelter syndrome, or Turner syndrome, or Jacob syndrome, or any of the other syndromes that you'll need to learn about in Bio 30.